Now children, in this session, let's calculate how to find out the distance between AB. But if we observe, neither are those 2 points lying either on the axis, nor are those 2 points, when you draw a line joining them, parallel to x-axis, neither they are parallel to y-axis. But if seen, they are slanted in the xy plane. Then how do we calculate the distance between AB? For this, we have to recall Pythagoras theorem. To apply Pythagoras theorem to find out distance AB, first let's see how we convert this segment drawn in the xy plane to a right angled triangle. So children, to begin with, we have to drop a perpendicular from point B towards the x-axis. So this is a perpendicular drawn from point B towards the x-axis. Similarly, let's drop a perpendicular from point A. Cutting this first perpendicular, you can name it as BC. So here we are. Let's mark this as point D. If we see, triangle ADB forms a right angled triangle, and we know what is AB. It is the hypotenuse. It is the side opposite the angle which is making equal to 90 degrees measurement. So triangle ADB forms a right angled triangle, and in this AB is the hypotenuse, and we have to calculate the length of AB. In Pythagoras theorem, how do we calculate the length of the hypotenuse? It is always hypotenuse is equal to, or length AB is equal to side 1 square plus side 2 square. That means hypotenuse will be equal to square root of side 1 square plus side 2 square. What is this side 1 and what is this side 2? Side 1 will be either AD or BD. Side 2, that is AD. In other words, how do you calculate the hypotenuse? What does your Pythagoras theorem say? That AB square is equal to AD square plus BD square. In other words, the length of the hypotenuse is equal to the square root of AD square plus BD square, which here we have represented as side 1 and side 2. But for this, first we will have to calculate what is the distance that is of side 1, that is over here marked as BD, and side AD. If we look into the coordinates of point A are given as x1, y1, and the coordinates of point B are given as x2, y2. Let's find out the coordinates of point D. If we look at point D or segment BD, it is parallel to y-axis. So the x-coordinate remains the same. So the x-coordinate will be x2, and if you see D when it is joined with A, AD is parallel to your x-axis. So your y-coordinate remains the same. And what is the y-coordinate? y1. So ultimately the coordinates of point D are x2 and y1. So now it becomes easier for us to calculate the distance BD and to calculate the distance AD. First, distance BD. If we remember children, if we observe BD, it is parallel to y-axis. So x-coordinate remains same. So how do we get distance BD? Only by taking the difference of the y-coordinates. That will be y2 minus y1. Similarly, let's calculate distance AD. Again, if we observe, AD is parallel to your x-axis. So any segment or any line which is parallel to x-axis, y-coordinate remains same. So how do you get the distance? By taking the difference of the x-coordinates, that is x2 minus x1. So here we are children. We got distance BD, we got distance AB. So how do you get AB now? That is the length of the hypotenuse, and ultimately our answer, which they have told us to find out, that is distance AB. Distance AB will be equal to AD square, that is x2 minus x1 the whole square, plus the length of BD square, that is y2 minus y1 the whole square. So to generalize, children, whenever they give you 2 points in any quadrant lying in a slanting position with coordinates x1 y1 and x2 y2, as they are given over here, x1 y1, x2 y2, and when you join them and you are supposed to find out the distance between those 2 points, the formula that we use is square root of the difference, that is the square root of addition of squares of the difference of the x coordinates and the y coordinates. To simplify it, square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. This will ultimately give us the distance between the two endpoints of that given segment, whether the points are lying in the same quadrant or whether they are lying in different quadrants. This is also called as distance formula. So again, children, we conclude that what is distance formula? It is the distance between any 2 points lying in any quadrant in an xy plane, and the formula is distance between those 2 points is equal to square root of the square of the distance between the x coordinates plus the square of the distance difference between the y coordinates, that is square root of x2 minus x1 the whole square plus y2 minus y1 the whole square.